Okay, class, good afternoon. So let us now proceed to the second part of the presentation and hydroelectric power plant. So this presentation class gives you the example, okay, solving problem in hydroelectric power plant. Okay, so let us now class consider this example. Francis turbine is installed with a vertical drop tube. The total head to the center of the spiral casing at the inlet is 45 meters, and velocity of the water at the inlet is 14 meters per second. The discharge is 4 cubic meters per second. The hydraulic efficiency is 83%. The overall efficiency is 0.88. The velocities at the inlet and exit of the drop tube is 2 meters. Water below the center line of the spiral casing, while the tail raised water is 5 meters from the top of the drop tube. So neglect velocities of whirl and leakages or leakage losses. So what is the total head of the turbine in meters? Okay, well, as a class, consider this example. Okay, so we have here the given height 45 meters, velocity of 14 meters per second. The hydraulic efficiency is 83, and the total is 88. So that requires the total head of the turbine. So here is now class the solution. So total head is of course the summation of the pressure head, elevation head, and the velocity head. Okay, so substituting now the value. So the pressure is of course 45 plus say, so the inlet and the outlet, so 2 plus 5 plus the square of the velocity. So the velocity of course, or the final, is 0. Okay, divided by 2 over 9.81. So the total head now is 61.99 meters. Okay, so this is very easy. So another, Pilton wheel is to be designed to run at 650 rpm under an effective head of 275 meters. The ratio of the nozzle diameter to the diameter of the pitch circle is 1/16. So assuming an efficiency of 79%, what is the size of the wheel in meters? So assume speed ratio of 0.64. Okay, so this is the peripheral coefficient, 0.64. The speed is 650. Total head 275. Okay, gravitational is acceleration 9.1 meter per second square. Okay, so from the definition, we have here the peripheral coefficient, which is pi dn, or the speed of the runner divided by the velocity of the jet. Okay, substituting values now, the diameter is 1.38 meters. Okay, another class we have, in a 13,000 kilowatt hydroelectric plant, the overall efficiency is 83%. The actual power received by the customer is 147,000 kilowatt hours for that day. So what is the secondary power could this plant deliver during the entire day? Okay, so we have here given, so power of 13 kilowatts, okay, efficiency of 88%. So we have here the energy 147,000 kilowatt hours. Okay, so required secondary power. So we have now here 13,000 times 24 hours operation. So that is multiplied by the efficiency. So that is 258,960 kilowatt hours. Okay, so we have now here the actual power received by the customer. So 147. Okay, subtracting now the two we have here, 11,960 kilowatt hours. So therefore the secondary power is 11,960 kilowatt hours. Thank you very much, class. Okay, that's all about my presentation.